Hello, welcome back to the last video in this series that is supposed to explain the twin paradox in simple terms. And last time we stopped here and we saw that from John's point of view, doing the analysis using the Lorentz equations, Mary has aged less during her round trip. Next, I will discuss the same paradox from John's point of view, from Mary's point of view, and of course Mary is in a non-inertial system, and usually, as you know from textbooks, special theory of relativity cannot be applied in non-inertial systems. For that case, you have the general theory of relativity. But what I like about Richard Muller's paper is that he shows that you can get the correct equation from Mary's point of view too, by just using the special theory of relativity. And I'll move to the next slide. So as you have seen, when Mary takes the round trip, you'll have, and John is standing behind and does the calculations. He calculates Tm to be equal to that. Now, a principle of special relativity states that only relative motion has a meaning. In other words, you can consider that relative to Mary, John is moving away and coming back. And then, from Mary's point of view, you can write this equation, which leads to this equation, and this is in contradiction with the previous equation that we got on the previous slide. So somewhere we have an error, and where is the error? The answer is, of course, like I was saying before, that the two reference systems are not really equivalent, since at least during the round trip, since Mary's system is non-inertial, meaning that she feels an acceleration when she leaves John, when she turns around, and when she joins John in the end. The special relativity equations are usually applicable only to inertial systems. So to circumvent this limitation, we should realize that when Mary turns around, she changes from a system with velocity v to one with zero velocity, and then to one with minus v velocity. And again, for simplification, we'll assume that these accelerations and decelerations happen instantaneously. Now, as we've seen in our previous analysis with the clocks, because of the fact that she feels these sudden accelerations, because she's in this non-inertial system, the time interval between the clicks of Mary's versus John's clock will suffer a jump, as we've seen. And we know that this jump, which, like I was saying before, can be understood also in terms of the relativity of simultaneity, is 2 times this quantity, which you can easily see from Lorentz equations. 2 times because the velocity changes from minus v to v, and not just from 0 to v, or from v to 0. Now, you have this jump, you have to add this jump to delta tj, and this will give you the desired equation, which is delta tm equals delta tj divided by gamma, and so you get no contradiction with John's point of view. Final remark: Mary feels an acceleration at the beginning and at the end of her trip, not just at the turning point of her trip. However, that doesn't introduce any correction to the time, since the clicks of the 2 clocks, of Mary's and John's clock, are not spatially separated. Basically, when Mary leaves and when Mary comes back, she touches John, you could say. So they occupy the same space. Thank you for watching these videos. This concludes my explanation of the twin paradox. Goodbye.